Okay, now we begin the fun part, the panel discussion. So we have a few questions for our esteemed panelists. And let me start with you, Eric. You've talked a lot about autonomy, and obviously Caterpillar is doing a lot, one of the leaders in the world. So what challenges do you see as the most important for enabling supervised autonomy of construction assets on the moon?
Okay. Well, I think there's going to be all kinds of challenges. But as I talked about relative to autonomy and the difficulties it was for us, right, with current platforms, and now you're putting it on brand new and et cetera. The other advantage that we have is that we have humans are still involved in the systems in all of those, even with the mining trucks, right? And we have the ability to deal with things very quickly locally as well. And I think that that's going to be a challenge if you're trying to do autonomy and you're trying to put an asset down and expect that it's going to run autonomously and not have to have any human intervention. That's going to be a real struggle, right? So the ability, and as you come up with your concepts of operations and so on, what are ways, and there's certainly communication latency and so on involved in here, but what are ways to construct that where you can still have human involvement, where humans can, because this is all going to be very new, and where you can be successful with autonomy is where it's very repetitive. It's well-known repetitive applications and trying to make that autonomous. But anytime it's new and problem solving has to happen and happen quickly, there's no replacement for humans. Humans are really quite amazing, quite amazing. And so how do you get humans still to be able to be involved with the challenges you're going to have with communication latencies and so on, especially early on until they can be present on the surface.
So on that note, terrestrial manufacturing companies nowadays, they're talking a lot about cobots, collaborative robots. You know? So where do you see that paradigm playing out on the moon? Use of collaborative robots.
Sure. So in the terrestrial construction, earth moving, we refer to as earth moving. I suppose you'll refer to it as regolith moving kinds of applications. We do have machine collaboration. Now that's done today through human operators, but there's machine collaboration. And so an example is how much material you're moving, how far do you have to move it, right? If it's a short distance, oftentimes a track type tractor or a dozer may be the more appropriate platform, and perhaps there's multiple of those, so they're each assigned an area, but there's that single platform. If you are trying to move it over a little bit longer distance, now it may be a wheel tractor scraper type of a platform is more appropriate. Now those systems are set up to be able to have a collaborative structure called push-pull. So two of them are always operating together in that case, and they actually mate and connect to each other. And so as the first machine is loading, the machine behind it is helping to push it. So they're both contributing to the tractive effort of the excavation. Then after the first one's complete, it pulls out its engagement, the bowl's engagement with the earth, and it's helping to pull the second one through. So they're collaborating in terms of their tractive effort to perform that function. And then if the distance is even further, then it's very typical that you're having an excavation platform like a hydraulic excavator that is now loading a transporter or hauling platform, a truck. And that takes it to a location, dumps it, and then you have a dozer that's now going to spread that material. So there's different ways in which these different kinds of machines are working and coordinating collaboration with each other.
Thank you. Keith, let me come to you. Bechtel has done a lot of projects, especially I'm referring to mega projects, huge projects, airports, subway networks and whatnot, and on Earth. And who knows, you might end up doing something similar on the moon. Right? So what are some of the project delivery methods you think are best suited for this kind of a Earth-Moon paradigm?
Yeah, so I think if you take a look at traditional project delivery models, right, you've got sort of the most traditional is design, bid, build, right? So I think that's always the one that everybody thinks about in terms of we're going to completely design a solution. We're going to let it out for bid, and then we're going to contract it, right? I think that in terms of something like this, in an environment that has unfamiliar, unfamiliar conditions, uncertain conditions, things are going to change on a regular basis. The ability to go to a more traditional design build, some sort of private public partnership solution, I think really enables the teams to be a little bit more nimble on their feet in terms of thinking through some of the complex issues that are going to come up on projects like this. Take advantage of constructability discussions at the very beginning of the job. Our preferred delivery method is what we call engineering, procure, and construct, EPC, which enables us to design specifically for how we're going to build it, right? And I think that having the end in mind, starting with the end in mind, how do you operate it? How do you start up and commission it? Working your way back through all of those complexities into the design phase, working through the design deliverables into the logistics part of it is going to be so complex when you work through a project delivering a project that's being delivered, that an integrated approach is going to have to be required, with the ability to adapt to change quickly, with the expectation that things are going to go wrong.
Oh, okay, sorry. So a follow-up to that, Keith. So do you think some kind of a consortium or some kind of a collaboration is warranted between terrestrial infrastructure companies such as yours and space agencies such as NASA? Or something we should start so that we understand, we hash out the programmatic aspects, the workflow processes and something like that, so that when we actually get down to it, the collaboration becomes easier between these entities.
Yeah, I mean, absolutely, I do. I think the more interaction that we can have with the government agencies, the more that we can learn about what their priorities are, what their objectives are, the more it helps us to shape what we're going to go out and develop in terms of our internal capabilities, whether that's personnel development, bringing on the right people to take on these challenges, develop our internal capabilities in terms of our knowledge base, which I do want to point out, there is so much interest in terms of the lunar construction aspect of the industry and internally in Bechtel. Every time that we put something up about it, there's always a huge reaction. So the pull is there from our internal counterparts and my colleagues. I think that we just need to figure out a better way to organize, I guess. How do we collaborate? How do we set up our organization? How do we develop that master plan that's going to give some insights to our senior management of what the long-term outlook is going to look like? Maybe obviously it's going to change over time, but at least we can start to formulate that and have better conversations and plan more effectively and efficiently down the road.
Great. Thank you. Leslie, coming to you. Moon is a different ball game, as you mentioned. So in this context, how important do you think are concepts such as modularity, mobility, and multi-use of ENC equipment on the moon? Could you share your thoughts on this?
Yes, pretty much just like here on Earth. It helps the efficiency and it reduces our footprint on the environment. The lunar environment, of course, is very different from Earth. It doesn't have life aspects to it, but sustainability is an important part of that. And modularity, if you can create equipment with different capabilities or technologies that can accomplish different tasks and in different areas, and if they can interact with each other, standards are important for that. And the reuse of things, just any efficiency improving practice will be even more important on the moon, because we don't have millennia of human experience there, which is what much of our current engineering is based on. So they'll be very important. They may not quite be the same perspectives as we're used to here. And that's what I mean when I said our preconceived ideas may lead us astray just a bit, but we can't wait until everything's perfect until we actually go up there and try some of these things out. And we will need to expect very low efficiencies, very low equipment availability fractions, uh, because we're not going to have everything perfect the first time around, and probably not the 10th time around. But if we do something that just gets us started and say, oh, that thing froze up sooner than we thought. How can we change that? And just incrementally work on what we have built, not just on Earth, but what we have figured out once we're in the moon, in the lunar regolith and the Mars regolith, and whatever flying gravel pit of an asteroid that we have to deal with. So those are important concepts, but it's not necessarily anything new on the moon than it is on Earth. It's just we have to look at it from different eyes.
Talking about looking at things from different eyes, Leslie, an important thing that keeps us awake is reliability and maintenance of assets on the moon. So do you think we should look at reliability and maintenance of construction assets for use on the moon in a different light, in a different way than we are used to terrestrially?
I think to start with, we should do it pretty much the way we're used to because we're familiar with that, with some changes. For example, just for working in gravity. And so I think looking at what the Apollo missions, what they ran into for trying to do things, trying to drill into the ground, some of the issues that they had with the first drill they tried, gives us some idea of where to go. But we should start with what we know and not change something that we're not certain needs to be changed, and go forward and just be smart about it, but not too, we don't want to study it too much before we go. Otherwise, we don't want to paralyze ourselves with analysis. So we do need to pay attention and follow some of basically the same procedures, the same idea, the same philosophy in repeat and robustness and flexibility of not just the equipment, but the processes of procedures, and modify them as needed as we go forward.
Thank you. Keith, a question for you from Slido. What is the envisioned time scale, example, 10 years, 20 years, and so on, for lunar construction sustainability from Bechtel's perspective?
That's a really good question. I think that based on some of the development that I've seen going on today, I think it's probably a longer term, maybe 10, 15 years. Overall, I think that it's going to be incremental gains. And I think that we have to manage that and be strategic about what we do go up there with, as was mentioned a minute ago. But I think that the faster that we go to the moon, the more that we're going to learn, the more that we are going to be able to adapt and fail. I would say, I think that we have to be open to some things that just aren't going to work, and that's okay. But I think that the more that we learn, the quicker that we learn, the more that we can scale, the more that we can implement those learnings, and then the faster that we can grow into a more sustainable economy.
Thank you. Eric, Caterpillar is big in mining. So what are the major takeaways from implementing terrestrial mining supervised autonomy that can be used for developing similar capabilities for the moon? What's your take on this?
Yeah, so I think one of the key things that we have learned in the implementation of this autonomy in mining is that you don't have to rely totally on just the technology, right? And so in the mining industry, and I think these things are going to be very true for this community and the lunar surface. In the mining industry, there's the ability to work with that customer and do a lot relative to control of the process on the site, modification of process to align better to autonomy and so on. So there's a whole area of the process itself. And then in the area of training, so there's humans involved, right, in the system in all areas. and the ability to train fully all of the humans that are involved in that system and the interactions, right? Those two areas can offset a lot of what you'd have to put into the technology side if you try to do it all from there. Like in the automotive autonomy sector, right? Much more of it has to be in the technology side because they have a lot less control over what's happening, the process, and certainly the humans and the level of training they have and so on. So they have to put it in the technology side. And so I would encourage this community to keep that obviously in mind and take advantage of the areas so you don't have to do everything through the technology.
Thank you very much. Leslie, let me come to you. Wear and tear, that's another big thing that comes up again and again. And that goes hand in hand with maintenance and repairability. So what's your take on the state of the knowledge we have right now on wear and tear construction equipments on the moon can withstand? And how should we design?
Well, construction and excavation equipment are now on Earth designed to generally the maximum expected forces, not the average, because there's a lot that's unknown about the ground when you're dealing with it. They say you don't know what you have until you've already had it, and even then you might not be sure. So when you're designing equipment on the Earth, generally we over design in terms of mass. We generally can afford more mass better than we can afford more power. On the moon, that's going to be a little different, where again, we don't understand all the properties of every little cubic centimeter of regolith we're going to deal with. So there's that uncertainty, and we also don't have much experience doing it. So that adds a lot more uncertainty. But for the transition stage, where we're still operating mostly from Earth, even though we'll have activity on the moon, it'll still be very Earth centric, then we'll need to just increase or we will still be limited by launch mass. But once we do have manufacturing or at least maintenance, but especially manufacturing capability on the moon for not just pieces, parts, but eventually equipment, then we can possibly loosen that mass constraint, that launch mass constraint somewhat. Partly our experience here on Earth has been that we get the reaction masses, the reaction forces for digging and for construction from the mass. But on the moon, of course, that's discounted by quite a bit, 83% or so. And so that's where some of our intuition won't work too well. So the intermediate stage where it's Earth focused, Earth centered, will be fairly difficult. But once we actually get onto the moon and have experience with the lower gravity environment, we will, I think, be able to work out procedures and processes that make it work a lot more easily than we'd ever really imagine here on Earth, where we have to simulate the lunar environment with a lot of money, a lot of difficulty, and generally not all at once. The gravity part, of course, is the most difficult. So I think there'll be some stages there, and the wear and the tear will be somewhat different, but there also is going to be some commonality because excavation equipment here on Earth, especially as Eric pointed out, the bits, the teeth, the engagement points where the machines interact with the natural material, there's always been wear and there's always going to be wear. Now, the patterns may change somewhat, but in large measure, many of the equipment design practices that we have will still be useful, either in this stage or in the later stage when we're starting to build actual equipment on the moon.
Thank you. Thank you very much. So I think we can continue this discussion over lunch right now. So let's break for lunch. But before that, I'd like to give a big thanks to our panel members. Thank you very much. Thank you, everybody. A great round of applause, please. Thank you. And Rachel would like to mention. Slide it.